like if he graded us, don't deduct for you, just for me. I'm the one who forgot to push the button. Okay, we're live now.
Okay, sweet.
All right. Mm-hmm.
So, should we just go through the assignment real quick?
Yeah, I'm good with that.
Okay.
I can start with number 1. You want me to do that, or do you want to? Okay. So one of the two conditions must be satisfied in order for the distribution of sample means to be normally distributed, and that is it either has to say that it's a normal population, or it has to have a large sample, and a large sample is anything greater than 30 usually.
Mm-hmm. Great. Number 2. What is the z-score formula for a sample mean that is normally distributed? 1 is, so z equals the sample size, or no, x minus the mean over the standard deviation divided by the square root. That's kind of a complicated, it's like a, but
it is.
Practice out more with the formula.
Yeah.
I think, but
I usually, what I try and do is get the standard deviation. I do the bottom first and then the top and divide it by what the answer was on the bottom.
Yeah.
You know, there's a picture of you, but you don't, when you talk, the screen's all black now. Is your camera on?
Really?
You were there at the beginning.
Huh. I don't know if it has to do with my laptop because it's kind of old. With Google Hangouts, I think it drains a lot of like Wi-Fi. Low, or it could be like just not super. So you can't see me right now?
Nope.
Really?
And I couldn't.
Talking to nobody.
At least I hear your voice, so we're all good there.
Okay.
All right. So number 3. Suppose a normally distributed population has a mean, or mu equals 10, and a population standard deviation equals 5. What is the probability a randomly selected individual observation is between 5 and 15? And so I watched the homework video for this one.
Mm-hmm.
Because I didn't get it. I don't want to tell you stuff you already know. So did you know how they got the answer is 68%?
Yeah.
Okay. So I don't know. I think too much sometimes, and I'm always trying to add all these extra things in. So when I watch the homework, I'm like, oh, that's easy. I get it.
It's so true, though. It happens to me all the time, and especially in math.
Yeah.
Because you're thinking like way too hard, and then you're just like, no, just use this formula or just do this, and it's like, oh.
It's like, oh, I could have had that done an hour ago if I would have done it that way. So
yeah.
Right. And then B, what is the 40th percentile for the population?
Mm-hmm.
It is, I guess, negative 0.253 is the z-score for that. And then C is what's the z-score for an observation of 18.5, and you do the 18.5 minus 10 divided by 5, so the z-score is 1.7. And what's the probability that an individual observation is greater than 12? And that's 0.344 plus, okay, so wait.
Let's see.
Well, hello.
Sorry, I just woke up.
Uh-oh. Well, we are on number 3, the E.
on the and I learn?
The
The quiz?
no, not the quiz.
Oh. Okay, let me open. Let me see.
Are you still on, Ryan?
So,
I think Ryan. I don't know what happened to Ryan.
I don't know either. Sorry, I just woke up from the nap, then I was in the couch.
Well, his box is still there. It's like he's still here. Ryan, if you can hear us, we can't hear you or see you.
No, I think I kicked him out.
You kicked him out.
Yeah, no, just kidding.
That wasn't nice.
I know, how rude.
Yeah.
Why you need to be so rude?
All right, we'll see. All right, and then 3E was what's the probability that an individual observation is less than 8 or greater than 12? You would add the 0.3446 to 0.3446, and you come up with 0.6892, 0.6892, so like 69%.
Would be. There we go. And I still open this thingy.
Oh, okay.
So what happened with Kira? I never cannot pronounce her name.
Yeah, I don't know. Kira.
Do I want to save? Sure. Do I need? Okay, which one are you now? Letter number.
Part 2, number 4.
Number 4, sample size 40. That one? I mean 4.
Uh-huh. Mm-hmm.
Okay.
So do you want to answer that one?
That will be part 2, number 4.
Yeah.
That would be. Let me read it very quick. The example for site taken from a normal distributed sales 2011 sales data. What is the shape or distribution of X? I go for normal.
Yep, it is. And you know why?
Because I see. I only guess.
Okay.
Sorry.
Okay. So this is how you know if it's normal. This is one thing I actually understand. So in the sentence there, it says it is a normally distributed. So that means it's normal.
Normally. So that means everything else, 5, 6, and 4, 5, and 6 is normal?
Well, so 4 is normal and 5 is normal for 2 reasons. First of all, it says it's normal, and then the sample size is what's considered large. If the sample size is over 30, it's a large sample size, so it'll be normal.
Oh, sweet.
Yeah, that's about all that I know really well. So,
I mean, that's good.
so number 6, a sample size n equals 4 is taken from the normal distributed 2011 sales data. What is the probability that the observed means is less than 40? So you would take the sample size is 40, and you subtract that from the mean, which is 45,
Okay, Ryan is here. Sorry, I was texting then.
Okay. And then you divide that by the standard deviation, which is...
Why you say goodbye, and
There you
I'll
are.
say hello.
Hello, hello.
Hello, hello.
All right, you're back.
Okay. That was odd.
Yeah, it was. Well, Kenny did it on purpose, he said.
Yeah, I kicked you out.
Oh, you did? That's
Yeah.
not very nice.
That was so rude.
That's fine, though.
And then you divide that by the square root of...
Kira text.
Yep.
Oh my gosh. Anyway, we can continue.
All
You
right.
can text. You want to text her? I text her.
You can, that's fine.
Okay.
Okay. So we're on number 7.
Oh, okay. Let's see. You want me to go?
Yeah, might as well.
Okay. The sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x value is greater than 35 and less than 55? So that, the answer says the probability is about 0.95 using the 68, 95, and 99.7 rule. So it's 95%.
Right, because for 2 reasons. If you figure out the z-score for 35 and then for 55, and you put those both in, and then the middle area is 95, but also the mean is 45, and the standard deviation is 20. Is 10. So 45
yeah.
minus or plus 20, which is 2 standard deviations, is the 95.
Yeah, that makes a lot of sense.
Thank heavens for the homework tape video.
Oh yeah, as soon as you discovered that, I was so happy. I was like, yes.
I get that.
Because before we were just winging it.
Number 8 is a sample size n is 25 is taken from the normally distributed 2011 sales data. What is the probability that x is greater than 41 and less than 49? And so again, you figure out for 45 and 41 the z-score, and you put it in the applet, and it's the same thing. It's 95%.
Okay.
It's 2 standard deviations.
You only change the numbers, right?
You got it. But you have to figure out the z-score for each.
Okay.
And like Ryan said, we need lots of practice in that.
I think, yeah, just a little bit, but.
You know, my problem is I don't know when to use what formula. And I got to figure that out. I got to figure out how to make sense of it.
Yeah.
I don't know. Do you want to do 9, Kenny?
9. Example size n equal 25 is taken from a normally distributed 2011 sale data. What is the probability that the observed x is greater than 50? Well, we take the probability from x, and because it's bigger than 50, what is it? Help.
So you figure out the z-score, which is 2.5, and you put that in the applet, and since it's greater than, it's to the right of the 2.5. Okay. So once you put that in, the area shows up as 0.0062. So that's what the answer is. So if it's greater than, it's to the right of whatever number you have in there, and if it's less than, it's everything to the left of it.
Okay.
Yes.
It is
Because less than
going,
and left start with L's. That's from
going
when I was in high school a gazillion years ago.
to the right.
Like 5 years ago?
Yes, something like that. Plus 20 or 30 or something like that.
I am 16 years ago for me.
Well, mine's more than double than that. I probably graduated before your parents were even married. Probably before they were born.
No, I don't think
No.
so.
That's okay.
I think maybe when they were dating. I don't know. Just kidding.
Oh, wow.
Anyway.
Yep.
So
So,
the next one.
mhm.
Should I do that?
Go
Okay.
ahead.
Paracomputing sold an average of mu equals 40 p phones per minute in 2010 with a standard deviation of 12. And they looked at their p phones sales data and determined that the distribution is right skewed. Number 10, samples of size n equals 4 are taken from the right skewed 2010 p phone sales data. What is the shape of the distribution of x? So I think that would be right skewed.
Yep. You are correct.
Sweet.
Because
You know the answer to 11.
I
Kenny.
should.
You do.
Let me see. Let's
Because
say right Q
No, what's the sample size?
is equal 40.
Which is greater than 30, so it is
Right Q.
normal.
Oh shoot.
Remember,
I should know that.
I know.
Let me put it here, and that way I don't forget it again.
You better not. No. Remember, if the sample size is greater than 30, no matter if it's right skewed or left skewed, it's normal because the sample size is large.
Then 30
And
is normal. Sorry. There we go.
and in
I put it.
the answers, on the answers it says it's approximately normal. Do you think we'll need to have that approximately, or we can just put normal?
I think we can just put normal.
Oh, okay.
I put it in red, big, bold letters, words, and that way I can see it.
Number 12, is there a theorem that justifies your answer to question 11? Yep, it's the central limit, which I got this wrong. I don't know why. I mean, I know that the central limit has to do with the shape and the large number has to do with numbers, but like we said before, we think too much, or I overthink things, and I thought, well, it's a large number, so, but it's the central limit because it has to do with the shape.
Yeah. That's good. Okay, 13. A sample of size n equals 4 is taken from the right skewed 2010 p phone sales data, and you want to know the probability that the observed x less than 35. Can you compute this probability using the normal probability applet with the information you have, and why? So first off, that sample size is really small, so I don't think you'd be able to do that, use that applet.
You know what? You're right. You can't. And the reason why is because it's the normal applet. So if it's not normal, you can't use it.
Oh, that's right. Oh, yeah.
A normal probability applet, and it's not a normal.
That's one of those moments I just had, like.
I know. I'm telling you. That's why we all take the quiz together. Between us all, one of us will get it.
Oh, for sure. For sure.
Okay. You want one of us to do 14, Kenny? Or do you want to do it?
Let me see. Okay. Example side of side N36 is taken from the right queue. Yeah, 2010 unserved data. What is the probability that the observed X is greater than 36.5? What is the probability? 36 is greater than. So the formula for the probability is, I mean, I can say the number, but I know I can need to explain how do I do it, right?
Mm-hmm.
If we run it will be 96, right?
Right.
Percent.
Mm-hmm. Good job. Find the z, or the standard deviation, which is negative 1.75, and then you put that in, and it's just what you said, 96%. I don't know if we can use 96 or if we have to use 95.94.
I think it depends on if the question says round or not.
Okay.
Because if it says round, then you'd have to. If it says like use 3 decimal places, then you'd have to do that. So I guess we'd have to be careful on reading the question or the instructions.
Yeah.
Or else you can get like the whole quiz wrong if you don't.
I know. And I'm pretty famous for that.
I did that in one of the homework quizzes. I didn't round it well, and I got like 2 out of 10 or something. And then I retook it and just rounded and used the decimal places and got 100.
Yay!
But yeah, it's important to read.
Yep, it is. It is. All right, I think we know how to do 15. Kind of the same thing. So it's the area, which is 7.887.
Yep.
So shall we try the quiz?
Let's do it.
Oh, no. Okay.
So all I have to do is find it, I guess.
7. Here we go. Okay.
All right. Do you have it up, Ryan?
That's normal. Were
you able to get it? Or are you still working on it?
It's still loading.
Okay.
Go on without me. Don't let me hold you back.
Doesn't matter. We need your brains.
Yeah. Okay. Starting to load the page.
$1.3.
So the first question is, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of negative 1.358.
Dang, I highly doubt I'll be able to use the applet. because it was like it's already slow just with Hangouts and the quiz still
True.
loading. But I might not be able to join you guys there.
Okay.
Dang.
So, oh no, what? Oh, okay. It says use the normal probability applet to find the combined area under the standard normal curve that is to the right and then to the left. So would we put, so if we put those z-scores in and then you say to the left and to the right and the answer is what's in the middle?
I think so, yeah, that's the area.
So it's 0.17, what's it say to
45.
do?
Like that, right? Do you see it, Ryan?
Uh-huh. So you
Hello.
have,
Hello.
Okay, I do.
Hello.
I see
Hello?
it.
Hello. And that way it only showed me.
look at you, you and your screen share, you're awesome. Okay, so it's 0.175.
Yeah, because we are using 3 numbers, right? Yeah.
Yep.
There we go.
Okay. Sweet.
Okay, 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? How are we supposed to know that? This confuses me.
Fine will be smaller standard deviation if 9 observations are randomly drawn.
I would say it can't be determined, but what do you guys think?
Which of the following have smaller deviation?
Wait. Okay, I'm finally able to scroll down to it. Which of the following have a smaller standard deviation if 9 observations are randomly drawn from a population? Distribution of individual observations.
9 observations.
Yeah, I don't think you can determine that. They don't give you enough information, I think.
Do you agree, Kenny?
Yeah, because we have only 9 observations, that's it.
Okay.
And we don't have the deviations.
So, which of the following results implies that that the spread in X decreases as the sample size increases? And I'm sorry, guys, is that the symbol for mean? That's the sample mean?
I thought that was the U.
Oh.
Or no, that might be the sample mean.
Which of the following results implies that the spread in the sample decreases as the sample size increases? Is that the law of large numbers?
Yes. Because you said the central limit theorem is that with the shape.
Right.
So it would be the law of large numbers.
What do you think, Kenny?
Well, if we go by elimination, it doesn't look like it's normal distribution because it's not normal, it's decreasing. Right?
Oh, okay.
And the rule of the 58, 59, I don't see any numbers, so we cannot use either. Yeah, let's go for the large numbers.
Okay. Okay. So scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8.
So that means I need to use Excel rules.
Okay. Diane earned a score of 160 on the quantitative portion. What is the z-score corresponding with Diane's score?
Diane's score. Z score.
Approximately 150.8. Standard deviation of 8.8.
So is it 160 minus 150.8 divided by 8.8? This is where I mess up, guys.
Let's see, so we're looking for the z-score.
U equals 150.8 deviation
Number 2
is 8.8 and the number is 160. Okay.
The only thing I can look at right now because of my internet is the notes or the worksheet we just did, and it says what is the z-score formula for a sample mean, and that's not what we're looking for, right?
Right. It's just the plain old z-score.
Mm-hmm. See, I think it would be. I'm gonna double check though on my phone, but I think it would be what you said.
So it's the variable minus the mean divided by the standard deviation, and the variable would be 160, right? Because the mean's 150.8.
Mm-hmm.
And then the standard deviation is 8.8.
Mm-hmm.
So
yeah, that sounds right.
So it's 160 minus 150.8 divided by 8.8 equals 1.045. What you guys got?
Minus. Oops. Divided by that. 1.45?
I got 0.45.
Oh, 0. Sorry. Yeah.
1.045.
Okay.
That's what I got.
Okay.
7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Above. Would we need to use the applet?
Oh, okay. Yeah, so we would put, okay. You are right.
Which number do I put?
1.045, and then it's greater than that, so you shade everything to the right. And so the area is 0.148.
That's the answer you said?
Yep.
0.148.
You get the same thing, Kenny?
No.
So this is what I did I used the applet and I put 1.045 in the z-score.
Mm-hmm.
And then it's greater, score above 160. So then I just shaded from the right over.
Mm-hmm.
And then the area is 0.148. Is that wrong?
Well, I put in, maybe I'm doing it wrong. I will show you. Where is it? Where are you guys? Let me see. There we go. So I put, I had it. We are using the normal probability applet. That thing.
Yep. So
And
put 1.045.
1.045. Okay.
Yep. And then take off the shading to the left.
This part.
Yep.
Oh. Okay.
Because it's above 160, and that's what that z-score is for.
Okay. Gotcha. It's 0.1480, right?
Yeah, but we only put 0.148.
Okay. Sweet. Wow.
Oh, you've been here, right? Oh, for about an hour or two? No, maybe an hour.
Did you see him come by yet?
Who?
The people you're supposed to come check today?
No. They don't come till 7:15. Well, 7:15 is when they start, and then after that, they come later, probably. But dude, it's looking. Okay. Sorry about that.
That's okay.
So are we on number 8 now?
Yep.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are these 5 scores. What is the z-score corresponding to the sample mean of these students' scores?
So their mean is 160.
Yes.
So it's the same as answer number 6? Is that right?
From the homework?
It's not letting me scroll.
Because you'd add 160 plus 175 plus 163 plus 149 plus 153. Divide that by 5, and it comes to 160.
Mm-hmm.
So the mean is 160.
Mm-hmm.
Oh.
Now we need to find the z-score.
Yeah, because the sample's 5, right?
Yes.
Okay, we have.
So it's 160 minus 150.8. And then and then 8.8 over the square root of 5. Is that how we would figure this out?
What happened with Ryan? He left?
I was just going to ask you what happened to Ryan. Oh no, did he get knocked out again?
I don't know.
Hey, he must have got knocked out. I'll invite him again. Just a second.
Okay, so we need to see a score corresponding sample size. Okay, so I need, for this one, I need to do the mean, the median, the standard deviation too, or no?
Oh my goodness. said that because I can't type to invite him. Okay, here we go. This is, I think this is what we were doing in the chapter 7 homework.
Yeah.
So, we need to find the square root of 5. Do you know what that is?
Okay. Oh, I got it. What is the mean? It's 60. You're right. 160.
Well, yeah, but I don't know that that's what we're supposed to. I think we're supposed to do something different on this one.
Yeah. What is the C-score corresponding or example? Okay. So the C-score, we need the standard deviation. We need the mean, and we had example size. So yeah. So mu is the mean, so that's 160.
There's
Hello?
Ryan. Hi.
Hombre, how rude.
Sorry, I don't know what's going on. I'm thinking maybe next class on Tuesday, if we even have it next week, of trying it on my phone, talking with you guys, and then just doing the homework, like doing everything on my laptop, like normal, like the class.
Oh. Mm-hmm.
That might work. So
Because
the
other option, it could be, hang out on or if you go to the library, you can use one of the computer to do it. I learned there, and your laptop for the
Do
Google.
they have a webcam?
No, you can use your computer for the Google Hangouts, but you just to do the
Well, that's
homework in the PC.
Oh, that's right. But I need to have my laptop plugged in, because if it's not, it dies within like 5 minutes.
A battery is $20.
I don't know if it's that. Something's wrong.
How long do you have your computer?
For almost 4 years.
Oh yeah, most of the batteries last long for 2 or 3 years. There we go. You had the answer.
I got a battery on Amazon for like $15 for my old laptop.
Yeah, that's what I say. $20 or $15 is one battery. So, anyway.
If you go to Best Buy or something like that, you're going to pay like $50, $60 for it.
Wow.
Yep.
I'll have to look into that and ask around, because that'd be nice to not have to always be plugged in.
Yep.
Mm-hmm.
Made a big difference. You just have to open up the back of your laptop, and it has the number of the battery, and then just plug that in Amazon, and they'll tell you how much it is.
Oh, okay. Yeah.
So this is what I did for this question. I took 160 minus 150.8 over 8.8 divided by the square root of 5. That answer to the bottom is 2.236. So I took 160 minus 150.8 divided by 2.236 equals 3.936. Or one moment, please. I have two answers circled. I don't know which one it is.
Wait, which question is this for?
This is number 9.
Oh, okay.
Oh wait,
what did
it's
you get?
not 8?
Oh, it's 8? Oh, okay. I was about to get really confused. Okay. Probability. Their scores.
Okay, the answer, well, for my answer, I got 4.144.
That sounds right.
4.114.
because the other number look kind of feel big.
Yeah.
Ryan, did you figure it out?
So no, my thing started doing that loading thing,
Okay.
and it like kind of whited out the screen, so I couldn't see it.
Okay.
Now it's starting to come back.
All right.
Sorry.
Okay.
Okay, now it's back.
All right.
So what was the answer again?
I have 4.114.
Okay, 4.114.
Yep.
Okay. See, number 9. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places. Probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem.
I have no idea how to even do that.
Begin that.
What is the probability that 5...
So we have n, it will be greater or equal than 5, right? That will be n.
The population is 5. Yep.
Okay, bigger or equal than 5. And then the mean score.
A mean score that is greater.
Oh yeah, the mean score is not the one before.
Oh, I don't know.
Because it said by the
That's the mean.
students in the previous problem.
So basically they're saying what's the probability that 5 randomly selected students will have a mean score that is higher than 160.
Yeah, kind of like that.
Yes. Because that was the mean score.
Oh, so we would put that in the applet?
Yes.
So we would put the 4.114 in the applet. So
What number? 4.44?
Yep, so the answer is 0. Because it's everything to the right of that.
So 0?
Yep,
So sad, no one passed.
I know. Because that number in the area is a mathematical equation for 0.
Okay.
Wow.
I really don't know that. That's what the homework said, so I'm going with it. It's my story and I'm sticking to it.
Yeah.
But you guys, honestly, I kind of stink at math, so, anytime you want
The only
to...
thing, I wish I had the applet, or I could use it, because that sounds... I don't know, I would think there would be a very small probability that one of them would score higher than the mean.
What, do you want to share your applet with, your screenshot thingy, Kenny, and put that 4.114 in? Or do you think
Yeah.
it's another number we're supposed to put in?
The z-score.
Okay, what do I put in the z-score?
4.114? Unless Ryan thinks it should be something different.
Well, it showed me that.
Mm-hmm.
It says error on the area.
And in the homework,
It's like,
what that's when I was watching the homework video, that said it was the mathematical equation for 0 because that was the answer to one of the homework, or not,
oh, okay. Well, if it's on that homework, it's got to be true.
Okay.
So let's do it.
Okay, 0.
0 it is. Oh, it's sad that you guys reason how I reason. That is not good.
Oh my gosh.
Why not?
Oh, mercy.
These ones are multiple choice. We're in luck. Suppose the mean GPA of BYU I students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? So, approximately normal?
That's what I would say because the sample is 81. So it's
Yes.
large.
Yep.
Oh man, Ryan, there was just one multiple.
Oh my gosh. Wow, sorry for getting you guys all excited.
How could you?
We only have 5 more, guys.
What is the
Okay.
mean distribution? Eh?
It's 3.5, right?
Wait, how did you get
Yeah, because the student standard deviation is 0.7.
Yeah, but it says what is the mean of the distribution of the sample
Oh,
means, and so the mean never changes.
yeah.
Or am I wrong?
What does the mean of the distribution of the sample means?
The mean, yeah, is 3.5. Because it said the mean of GPA of the BYU student is 3.5.
Yes.
What is the mean of the distribution of the sample means? For example, the 81 is 3.5. Okay, 3.5, I guess. I don't know, maybe I'm wrong.
Yeah, I think so.
Okay, so we all agree it's 3.5?
Yes.
Okay. What is the standard deviation of the distribution of the sample mean for all possible samples of size 81 that can be drawn from the parent population? So, what is the standard deviation of the distribution of the sample mean? So the mean is 3.5. The standard deviation is 0.7, and the sample for the population is 81.
My screen just did the loading sign again, so I can't see the question.
You want me to read it to you?
Yeah.
What is the standard deviation of the distribution of the sample means? And then in parentheses it says sampling distribution for all possible samples of size 81 that can be drawn from the parent population. Round your answer to 3 decimal places.
Deviation of
For all possibilities.
What is the standard deviation of the distribution? So do we just find the standard deviation of 81? No, I don't know.
What is that? What is the difference between the question before? Then we could be trapped. Oh, okay. In the first one they ask for about the mean, and this one is the standard deviation. So if we do the standard deviation, what formula is that one? What is it? Because the first one is about the mean, and this one is standard deviation. So we have 81. How do I do a standard deviation?
So the standard deviation of the distribution sample means equals the standard. What is the standard deviation of the distribution of the sample mean?
It's not 0.7? That's my
Okay,
guess.
so it says equals the standard deviation of the parent population divided by the square root of the sample size. But we don't have those numbers.
The example size now 81?
All right, but what's the parent population?
Oh. Well, I don't know. We don't know if they are alive or not. Oh.
Yeah, I'm confused.
Me too. I don't know what to do.
And it's
So
impossible to guess.
We need to
Did
find
you figure it out? Hey. Okay.
We need the parent.
Yeah.
How are we counting the parents? Are we counting like it's only one parent or two parents, or it's only 81?
Yeah, that's what I don't know. I mean, we have to find the parent population. Or else it's super easy and we just have to like use the applet and figure it out.
Let's see.
Okay, so we figured, well, that's the mean.
So the definition of parent population says the population from which a sample has been obtained.
Right, and we don't know that.
The population of the sample. Yeah, we don't know how many students there are. That's super difficult. Because it would be the population of BYU, Idaho, like how many students there are. Because that's the
Right.
population of the sample. But we don't know what it is.
Can we figure that out with these numbers?
I doubt it, but maybe.
Okay.
Sorry for being. Yeah, I don't see how we can figure that one out. Maybe we should just skip it and continue, and then
Well, we have
maybe
to.
something. What did you say?
I didn't know if we needed it for the other ones.
The next one says, what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? It doesn't sound like it.
So, okay, let's figure out the standard deviation for 81 students. Because to get answer number 13, don't we have to have the standard deviation?
The probability that the mean less than 3.3.
So what is the value of the sample?
Oh, okay. So suppose the mean for the GPA, so the GPA mean is 3.5. The standard deviation is 0.7. And they took 81 students. Okay, so what is the standard? Okay, so if we looked at 13, what is the probability that the mean for 81 is less than 3.3? So if the mean is 81 and we draw that bell shaped and let's use that 68, 95. So if we draw a line in the middle, that's 81.
Mm-hmm.
The standard deviation. Okay, so wait a minute. So what's the 3.5?
Ryan is gone again.
No, that's wrong. The middle would be 3.5. And then if we subtract 7 from 0.7 from 3.5, that's 2.8, and 3.5 plus 0.7 is, I don't know, guys.
I was trying to figure out which one is which one.
I don't know, would that be 68%? But
And Ryan is gone.
Ryan's gone again?
Yeah.
I don't know, Kenny.
Me tampoco. I mean, me neither.
I don't know if 14 is 68%. I don't know. I'm totally lost on question 13 and 14.
Well, we know the mean is 3.5, right?
Right.
81 is n. That would be right. So the first thing came to my mind is from the exercise and we did before when we were doing the less greater than 35 and less than 55. Remember part 2, number 7?
Yep.
That would be the formula that we might use. Think. The only thing we need to do only one, not two.
Yeah, okay.
Okay. Let me see. I think I did it wrong.
Hello.
Hello.
Finally.
I got on my phone.
All right. Cool.
Yeah. So if this goes down, then I don't think it will though, because
Okay.
phones are usually pretty. Well, at least my phone's fairly new, so it shouldn't be a problem.
Cool. We are stuck on number 12, 13, and 14.
Let's see. Standard deviation of the sample means. Yeah, number 12. I'm might be giving up on that one. I don't know. We might have to email. Like maybe we could take the quiz and submit it, and then just email Brother Balls and see if he can explain to us how to do that one before we take the quiz again.
Sure.
And then 13. What is the probability? The mean GPA. So for 13, do we need to calculate the z-score?
Yeah.
Okay. And then we need the applet.
Yeah, but I don't know how to calculate the z-score for that. I'm afraid.
Would it be 3.3 minus... divided by standard deviation. Oh. Let's see. Would it be...
Oh,
I think 3.3 minus 3.5 divided by 0.7?
Or it is just the standard deviation. Oh, wait. Yep, with the standard deviation, which is 0.7.
Mm-hmm.
Oops. 0.7 divided by the square root of the random sampling. This divided by the square root of 81.
Mm-hmm.
That's normal distribution with a mean of 266. This is in my notes.
Mm-hmm.
Standard deviation is 16. Random sample is 30. What is the mean, the standard deviation, and the shape of the mean based on 30 samples? So the mean is the 266 days, or would be our 3.5.
Mm-hmm.
And it said you take the standard deviation, which is 0.7, divided by the square root of the sample.
Mm-hmm.
So the square root of 81
Yes.
is 9. So 0.7 divided by 9 is 0.0777. Or I guess 0.078.
So that would be the z-score, right?
Yeah.
Okay, and then we need to enter that into the applet.
Yep. Well, Wait, that is that the answer? That's the answer to number 12.
Oh, okay.
Right. Kenny, are you still with us?
Yeah, I was trying to figure out the numbers too.
Okay.
So you said it was 0.078?
Yep,
Okay.
I think.
And then 13. So you just have to put that z-score into the applet.
I
And then
think.
see.
I don't know. Wait, 078.
Wait, can you guys see me?
I
Yeah.
don't think so.
Okay, I can't see myself either. Just checking.
How rude.
Sorry, my bad, lo siento.
Okay, so okay, so you put that number in the applet.
Mm-hmm.
Oh.
And then see which one will be less than 3.3.
But how do we know what's...
What number do I put here?
So, I don't know if for this one, to get the z-score, if it's the way you did it, or if it's like the 3.3 minus the mean, which is 3.5.
Okay. All right, what do you get for that? Oh.
And then divided by the standard deviation. I know that that's one way to do it, but I'm not sure if it applies in this situation.
Because that one, 3.5 minus 3.3 divided by 0.7?
No, it would be 3.3 minus 3.5. So it'd be a negative, and then you'd put that negative z-score on the left side. Or I guess you could put it on either side. But
Okay, so is that... Oh, I see what you're saying, Ryan. That's okay. So you take 3.3 minus 3.5, and that's 0.2, and you put negative 0.2, and you put that.
Which part do I choose?
So then you put everything to the left of that.
That? Like that?
I'm here. Oh, did we lose Ryan?
No, he's here, I think.
wait,
Ryan?
Can you still hear me?
Now we can.
Oh, okay.
Yeah, but we don't see you. How rude.
So
yeah, I don't see you either.
That's not my fault.
Too. I'm just kidding.
So then you put the z-score, the 0.078 in the z-score, the negative 0.078. Did you put that in the z-score part? And then shade it? No.
0.78?
Well, that's what 3.3 minus 3.5 is.
Those one is from the number that you give me.
Huh?
Yeah.
Negative 0.2857. So the z-score that I kind of calculated, which is the 3.3 minus 3.5 divided by the standard deviation, that was does that sound right, that formula?
You know what that does?
Okay. That's negative 0.286 as the z-score.
Okay, and then it's less than that, so you take everything to the left of it, right?
Yes.
So that's 0.387.
I had, well, the area shows like, see, I don't know.
That's the area is 0.3874.
Which one are we doing?
13,
Okay.
right? Ryan, we're doing 13, right?
Yeah.
Point 28, 27, 29.
0.2857. So 0.286.
What? What? That's not what I got. What?
For the standard deviation?
Oh, yeah.
The z-score, sorry.
Yeah. But the answer to the question is 0.387, right?
Oh, okay. Well, I can't calculate it, but
Okay, so I put that z-score in the applet, and then it's the area that's the answer, right?
yes, if you click to the left.
Left, right.
Yeah. Okay.
I mean, correct.
That should be right.
Okay, so it's 0.387. Oh my gosh.
Sorry.
No. Two more, guys. Two more. That's it.
Ooh. Let's see. What is the probability that the mean GPA for 81 people randomly selected at BYU, Idaho will be greater than 3.3?
Sweet. So we just do the same thing, but to the right?
Yes.
Hallelujah.
Praise the Lord. We all
And
gotta rise up and praise the Lord.
oh my goodness. And it's the same answer.
It is? Oh, yeah. It's the same.
Because it would be the same answer because it's the same percentage to the left or to the right.
Mm-hmm.
So 0.286. Right?
No, 0.387.
What? 0.276?
No.
0.387.
0.387. Man.
Is that right, Ryan?
Yes, that's right.
Oof, okay.
You say tomato, I say potato.
or potato.
Or potato.
As extreme or more extreme means that we are not only interested in values that are low. Holy cow. Okay, number 15. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boat accident. The standard deviations of passengers' weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answer to 3 decimal points. Oh, holy Toledo. All right. Nice and slow, boys. How do we figure this one out?
So, we had a mean 180 pounds, 85 pounds. We have standard deviation 26.7. Sweet. Standard sample.
Okay. So the sample, or the random sample, was 48.
Mm-hmm.
The sample mean was determined to be 177.6.
0.6.
Yep.
And
Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than the mean that was observed in this sample. So would we find the z-score for the two, for the 185 and the 177?
I don't think so.
No, I think I agree. So
I think of just the sample. So we need to use that formula, the crazy one. C equals X. So the observed value.
We are looking for
Minus 85 divided by 26.6. That divided by square root of 48. So that would be 177.6 minus 85, negative 7.4 divided by divided by root of 48. Well, that was wrong. Okay, so I have a z-score, but
did you get negative 1.068?
No.
Okay, what'd you get?
You got 1.92. Wait, negative 1.920.
Okay.
But you're the smart one, so I think we might need to use
Oh,
your.
oh no, I'm not. Oh,
Oh
you
yes,
never,
you are.
oh, we should never say that in math.
The only reason why I'm not 100% sure about it is just because the square root of 48 is not an even number. It was 6.928, and so that's how I entered it as 6.928. I don't know if I needed to round to 6.93 or if it really matters that much. I'm hoping it doesn't.
You know what? Wait a minute. I forgot a step.
Mm-hmm.
The square. No, you're right, Ryan.
So do I do 6.928?
You do.
Oh, okay.
That's the square root of 48.
Yes. I wasn't sure if I needed to round it to 6.93.
I know. I did 6.928 too.
Okay,
But
that's what I.
what do you divide that into? The 7.
So what I got was 177.6 minus 185 divided by 26.7 divided by the square root of 48.
Okay. And that came up to negative 1.92?
Yes.
Okay. Okay.
So do you guys put that in the applet?
I think we would.
Yeah.
Negative 1.920. And then, what did it say? Everything above and below? Or, wait.
Find the probability that a random sample of passengers will have a weight that is either above or below the mean.
An extreme or more extreme. Hmm. Well, it says on the note, as extreme or more extreme means that we are not only interested in the values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. So then would you put the z-score in and then shade everything to the left of it and then to the right of the z-score on the other side?
That's what I understand.
So it would be 0.055.
Okay. 0.055.
Hmm.
Is that what you guys got?
The only thing I confuse is between the sample mean and the mean. Which one go first?
The sample goes first, and then
Okay. Then the mean.
Yep.
Okay, and then because doing all the math, I had point 1.920.
negative.
Yeah, negative.
Uh-huh.
Yeah. So that one I put it in the thingy, right?
Yep, in the applet.
On the applet.
And then if you shade everything to the left of that, and then to the right of the z-score on the other end, then your area is
0.0274.
Uh-huh.
Okay.
No, wait, what'd you say?
0.0274.
No, I think it's 0.055. So shade everything to the left of, leave the middle unshaded.
Okay.
So to the left of the z-score and to the right of the on the other end to the right of that z-score. So to the left of negative 1.92 and to the right
And the
of
positive.
Yeah.
Okay. So that would be 0.0549.
Yeah, but
Am
I
I
think
doing it wrong?
right, and we're only supposed to do 3 decimal points.
Okay.
Are you still there,
So-
Ryan?
Yeah.
Okay. So do you agree it's 0.055?
I do.
All right. So shall we submit this sucker?
Let's do it. Woo!
We'll see how.
Did we do number 12? I don't remember doing number 12.
Oh, we got a whole bunch right. Whoa, we got 64.71%, guys. We suck tonight. Hey, we got number 15 right.
Yeah.
Oh, sweet.
We missed 14 and 13. Okay. And 8. We missed 8 and 9. Oh, gosh. Darn it. And we missed 4.
Oh, yeah, we meet 4.
Well, darn.
So we'll just have to study harder.
Yep.
Okay.
All right, guys, you think we're good?
Yeah, I'd say we've had a day.
I think so. All right. I will stop recording, I think. Let's see here. Let me get back over here.